So in simplifying radicals that have the same roots, you have a couple of choices, especially if there's just numbers under them. One thing you could do is multiply the 15 times the 75 and then put them under the same root symbol. So this would be the cube root of, and then when multiplying those together, it's 1,125. Then you've got to go down your perfect cube list and see which of those numbers divide evenly into 1,125. So, 2 times 2 times 2, 3s, 4s, 5s, you're looking at 125, nope, 625. Let me try that again. I think it's times 5, 125. All right, then if I do 6s, 6 times 6 times 6, you get 216, and so on. So, that could be a bit of a process, and then you see, well, what will divide into, off of this list, the number 1125. So, you can take your 1125 and divide by, I'm guessing 125, which is just a guess, and it went in evenly. Cube root of, and then 125, and then times 9. Then you can break the radical up into the perfect cube, 125, times the cube root of 9. Since 125 is on the list, that was 5 times 5 times 5. The cube root of 125 is 5, and then I have the cube root of 9 is left over. That's one way to do it. Another way to do it, and not quite so calculator heavy, is to take the cube root of 15 times the cube root of 75. But rather than multiply it out, I'm just going to create a factor tree. So for 15, I can break that up into 3 times 5. And then for the cube root of 75, I'm going to break 75 down. So 3 times 25, and then 5 times 5. All right, so anytime I see a group of 3 out of both of these, I circle it, and that number comes out. But it's got to be at the ends of the branches. I see 2 of these, but I don't have a third one, so it's going to be the cube root of, and then just put those underneath, 3 times 3. So 5 cube root of 3 times 3 is 9. And that's another way to get it. Sorry about the dog interruption there.